Hello, everyone. My name is Anna Slavic. I'm assistant professor at the University of Primorska. And this workshop is about research data sharing as part of open science communication. I'm not an expert on communication. My background is in social science, statistics, and in the recent years, I've been working a lot with open science at the open science projects at our university. And usually my lectures and seminars are about research data sharing. Today I will be talking about how research data sharing is an important part of open science communication and why, and how we can improve our communication or science communication by data sharing. So this is the out. Sorry, do you see this on my slide? Okay. So this is the outline of the presentation. I will talk first about science communication and about trust in science, then about the reproducibility and replication crisis in science. Then I will connect that to the research data life cycle and how we can communicate science in different phases of the research data life cycle. This is a workshop, so I want to make it interactive. There will be some slider questions in between, but also we will have a case study and discussion in the last part of the workshop. This is the first time I'm doing it, so maybe I will be your feedback regarding that will be very welcome. What you thought about the case study, and at the end I will share some links to some additional resources that can help you to improve your communication regarding data. Okay, so let's start by introducing the concept of what science communication is. I found here two definitions. First one is from the website Science Europe, and it says that that science communication is the practice of informing, raising awareness of science-related topics, and also getting involved with audiences. With audiences that include, at least in part, people from outside the science community. So, also the term science communication refers to communicating from people outside the science community. As I mentioned in the beginning, usually research data sharing is a topic that we talk about with when we talk about sharing our knowledge, with communicating with other scientists. But in this case today, I will talk about also how to communicate that maybe to people who are outside the science community, but are interested in science, are interested in the use of our data. And then here, another definition from Wikipedia, that science communication is informing non-experts about scientific findings, raising the public awareness of and interest in science, influencing people's attitudes and behaviors, informing public policy, and engaging with diverse communities to address societal problems. Also, two definitions which are very connected as a starting point. And okay, now there should be a slide. Okay, yeah, so I will jump to this slide. So I hope you're familiar with Slido. So this is a question that you can respond by going to slido.com and entering this code. You could do that now on your computer or on your mobile phone. So you type slido.com and then this number. And the question that I have is, what do you think are key characteristics of effective science communication? This is an open question, so you can type an open response, and the result will be a word cloud of all of your responses. And you can also type more than one response. So when you think about what are the characteristics of effective science communication in general, so what would you say? So I see that 4 participants are already typing. I will wait some time so that you can type so that you can enter Slido and then insert your responses, and then I will click. And also when I click and we will see results, you can still type and send out answers. And then we can see, so what are the key characteristics of effective science communication? What comes to your mind? So anything that comes to your mind, please type it. With, on the top, we have 8 people who already responded, 9. Okay, I will click on the results so that we already see some words, but still feel free to type 5 answers. Okay, we have 2 very big ones in the middle, accessibility and clarity. And then around we have is to understand, findable, transparency. Okay, we have also visual, transparency now increased in interesting here. Accessible language. Interesting. I already said that. I'm waiting for one response that I was expecting, but I don't see it yet. Okay, language. Many details. Okay, that's an interesting one. Not many details. People are still typing. So let's wait some more. Okay, the left button is vulgarization. Easy to understand, decolonizing knowledge, public awareness, participation, engagement, accessible language, active listening skills, available, legible, public, context, simplicity, real, public doing, prepare, humanize, art-based, using objects, rich, shortness, digital, not many details. So that one. Flexibility is now a bit bigger than others. Mediation, political context. Okay. I see we have 224 responses. One person is still typing. Maybe something I was expecting, but I don't see yet, is storytelling. So when I search for information about what is good science communication, often the word storytelling appears. So the ability to tell science through stories. So the ability to storytell is usually something, and maybe I'm missing it, but I don't see it in the responses. But yeah, so yeah, what stands out here maybe this transparency, accessibility, creativity. Yeah, maybe creativity is something related to the storytelling. Okay, I see some people are still typing. But yeah, let's continue. We will maybe come back because I have to go one slide back, where just an example of 3 articles, but some are popular science articles, some also scientific, but there are of course many more that mention this importance of storytelling. So that science should be told in form of stories. Okay. And now, okay, sorry. Okay. Now, yeah, so storytelling. When talking about storytelling, what is the role of data in storytelling? Here is a funny picture of like a grandfather telling a story to his grandkids, like and using also some data. Long time ago, in the 4th quarter of 2015, far away in this and this region, in a small customer demography. So this is like an example of how some like very specific data, some terminology that we use in scientific papers maybe is not appropriate if we want to do storytelling to the public, so to a wider audience, because they might not be interested in this technique, they might not understand, or they don't have an interest in all these details that we talk about. So usually a lot of times there is this advice, and I saw also in these characteristics of effective science communication that we were listing, that we should make things simple, avoid details. So like very specific data, it should be avoided in this storytelling format. But yeah, on the other hand, if we don't support our findings with data, then we are just a person with an opinion. We are not scientists. To do science, we have to base what we so when we speak. It needs to be based on facts, on data. So we shouldn't overlook the importance of data in science communication, and we also shouldn't underestimate our audience. So it's important that what we speak is based on data. And then another aspect of science communication, which is actually something that many of you, maybe not with this word, but you mentioned it, the importance of transparency. And there is also the question of trust. So does the public trust science? Well, here we have an image of some results presented with visualizations in your responses. What are key characteristics of effective science communication? You also listed the visualization as an important thing. So people don't like to look at, tables with raw data. They want to see some nice graphics because it's a lot of people are more visual, and they want, so it's better to present the data with some visuals. But, we should, as I said, we shouldn't underestimate the public. They might question, these visuals, what is behind them? Should we trust this data? And as you know, so garbage in, garbage out. So the quality of the data that is behind the visual is very important. So people can be very skeptical, and just showing them nice graphics, maybe it's not enough for them to trust our data. So we have to somehow also prove that our sources, that we have quality sources, so that our data is not garbage, but it's data that we can trust. But before we talk about how to make that, so how to communicate this trust, maybe let's look at what the data shows about this question. So does the public trust science? Let's look at some research data regarding this topic. Okay, here is some data from the United States, from the Pew Research Center. The question that was asked was about confidence in scientists. And there is data from 2019 to October last year. And we see that after the corona pandemic, there has been some decline in how much people trust scientists. So before that, it was so people saying a great deal. It was almost 40%, and then it decreased to less than 30%. And it stayed that way also now, so we can observe. And many people saying they don't trust science. Okay, but this is data from the United States. Do we have maybe similar data for Europe? We have. So here is data from the Eurobarometer study. And the question was, to what extent do you agree with the following statement regarding scientists today? We can no longer trust scientists to tell the truth about controversial scientific and technological issues because they depend more and more on money from industry. So, and the question was asked in a different way than the one in the United States, but it tells us about how much people in different countries trust science. I'm highlighting the 10 T4U countries. So out of the 11 countries, the 10 are here. I think only from the T4U countries, only Ukraine is missing. All the others were included in this study. And so you can see, so the agreement tells us, so the higher the agreement, so the blue color, so the agreement means that people don't trust science. So we see my country, Slovenia, is like the one of the most problematic ones. Also in Spain, this mistrust in science is high. And then we see also Lithuania, Bulgaria, Portugal, France, and Germany. This is like on average in Europe and the 27 countries in the European Union. And then there are some countries where this mistrust is lower than average. So people in these countries trust science more. And among the T4U countries, we see Italy, Poland, and Estonia is the one among T4U countries that has the best result here. But in general, in Europe, we see Ireland is the country that has the least problems with trust. Okay, so this is 2021, but in this United States data, we also saw they showed some trends. So how is this changing in time? So this is 2021. Eurobarometer has asked the same question 11 years ago in 2010. And here we can see for these countries what is the difference. So in total, for the European Union, so we look at the percentage of agreeing. So the more people agree with this statement, this means less trust. And we see that in all the 27 countries together, the decrease was 4 percentage points. So we see in total, there was this decrease, but it was different between different countries. In some countries, it was smaller, in some countries, bigger. But in general, the trend from 2010 to 2021, in total, we see a 4 percentage point decrease in the agreement with the statement. So actually, no, sorry. So this means that actually if there is some maybe improvement. No, actually, yeah, it's so the difference but we see that it's very different. So we see here Portugal, it stayed the same, Bulgaria and Spain just 1% difference, and when we have Poland, but Italy, it was the same as the total, but we see in some countries it was higher, for example, in Slovenia, Lithuania, France, Estonia, and Germany, it was much higher, this difference. There are, of course, many more indicators, many more questions in this study. Here is the link. These slides will be shared, so you can then later check the links. But this is an infographic that was published on this on the website of the study. Some additional results from this 2021 study. And there was a question, what are the characteristics that best describe scientists? And we see the highest percentage for intelligence, but actually also quite high we see for, very high, 2/3 said that reliability, but also honesty. So from this perspective, we see that most people still somehow trust scientists. But what is interesting and related to this topic, some people pointed out that scientists were bad at communicating. And then on the other side, we have the qualities that they would like to see. And honesty is on the second place. But interestingly, the ability, where is it? So communicating well is not very high on the priority list when they were telling what they want from us, but honesty, it was like very high. Okay, and now my question is, so we have another slide of question. It's the same number that you can type, so if you're still there, you can write the answer. And so the second question is, why do you believe trust in scientists is declining? So I'm interested to hear, what do you believe are the reasons why people don't, so that's why we can observe this decline in trust in scientists. What do you think are the reasons that the trust is declining? So what is the, what is happening that makes people don't trust science? Okay, I see 3 people already wrote something, 3 others are writing. So again, you can do it through your computer or mobile phone by typing slido.com and entering the number, or you can also just scan the QR code. Okay, 6 people are writing. And again, you can also, of course, write multiple responses. And we are at 8 respondents. Yeah. Thank you. So let's see if I click, if I can already see. Okay, fake news, like a big one, and the middle, and then around it we have populism, the COVID pandemic, lose interest for difficulty, more critical thinking, recycling research findings, deconstruction from the people, ignorance, media, too much info, trust, disbelief, scandals, articles, reduced creativity, lacking education, retractions, gaps in education, lack of interest, political climate, overcomplication. Okay, no more elitism. Scientists do not engage in public appearance enough. Responsibility, less human connection, globalization, misuse, ignorance, many sources of information, too much information sources, recycling research, false information, too much false information. Okay, now we see that reduced creativity, social media, political climate is now increased, lies, politics. Okay, but yeah, and like the neither. So people don't know what to trust. So there is so much information produced, and people are like somehow, immune to all this information because every day we are like bombarded with so much information, and it's difficult for people to believe also, because now with the new technologies, it's also you can fake facts, create fake videos, fake images, and experts might be able to detect what is fake news, but the general public is not always able to detect. So at the end, they decide like maybe not to trust anything because of this losing trust. So yeah, many reasons why this trust is declining. As some of you mentioned, there is also this problem of scandals and retractions in science. So there are some examples of fraud in science that are decreasing. And yeah, also too many times, often contradictory information. So at the end, and false information. So at the end, it's difficult to decide what to trust, what not to trust. Thank you for your responses. And now let's talk about the reproducibility and replication crisis in science. First, maybe a definition, because these two terms are sometimes used interchangeably, but actually they have a different meaning. Reproducibility refers to the ability to achieve consistent results using the same data and methods as the original study, and it should not be confused with replicability, which is obtaining similar results using different data. So reproducibility, we have same data, same analysis. Replicability, we have different data, same analysis. But both are of important. And then we have another two words when we talk about scientific findings. We say that they are robust, which is having some data in different analyses, but you get the same results. You would say that the findings are robust. And then there is this issue of generalizability. So we have different data, different analyses, but can we make, an inference? So this is another property of data. Let's look at two examples of these problems. The first one is an article about the challenges for assessing replicability in preclinical cancer biology. There are also similar articles in these other fields, like in psychology. But I like this one because of this visualization, so I included it. And here they found, based on different experiments, so they did an overview of different experiments and an analysis of what were the barriers. I was what was interesting to me is like here at the bottom, you see the data sharing was very low, so a low percentage openly shared the data, but more, of course, reported the analysis. So the analysis usually is reported, but very few studies are sharing their code. So it's not possible to reproduce findings if we don't know how the researchers got to the results. Of course, this is something that's most important to other researchers because other researchers are the ones that need to replicate studies, but also the public is more and more educated and more interested in science. And even if they're not scientists themselves, some of them maybe are working with data. They're working in other occupations that work with data, and maybe they're interested in science and they want to know, for example, especially during the COVID pandemic, people were home a lot and had a lot of time, and many people had time also to read scientific papers, reports related to the pandemic. And this was, one example when it was really important that what scientists published about the pandemic, that it was trustworthy because it was not only read by scientists, but also by others. And people notice these kind of things, that if you report just the analysis or you just share the data, because of course, if the data and code and the methodology is shared, we can trust the findings more. But in this research field, they found that there are quite some challenges when assessing the replicability, and similar studies were done also in other fields and came to the same conclusions, that there are a lot of barriers for replicability, and also, of course, the producibility of scientific findings. So one thing is, we have some results and to reproduce them, but then there is also an issue of error. And just, as an intro into the topic, we have different types of error. When we speak about errors in science, we have random errors that are unpredictable and happen by accident. But we also have systematic errors, which are more problematic because they occur due to a flaw in the procedure of system. For example, because of incorrect calibration of an instrument, and these systematic errors add up, and they cause some bias in the result. Regarding errors, we have also to distinguish between unintentional errors that happen due to inattention, lack of information or understanding, or incorrect assumptions. But we also what can happen is intentional errors due to various types of fraud with research data, such as fabrication, falsification, deception. Science can be very competitive in certain fields, so people who are competing for funding, they want to publish as much as possible, and sometimes these researchers they intentionally fabricate, falsify data in order to achieve results that they can publish, and this is a problem. So because this is something that then decreases the trust in science, it's important to be able to detect, and part of that, something that can help with that is, of course, transparency, and so sharing the methodology so that the studies are replicable and reproducible. And yeah, so there are many examples of that, but here I'm including one. As we found out at the beginning, people really like visual information, and there are a lot of manipulations with it can be a lot of manipulations with data. And here is an example. So there is this Dutch scientist, Elizabeth Bick, that is reviewing a lot of papers and looking for examples of image manipulation. And this is an image from one of her discoveries, where she discovered that some scientists, they just copied an image and present it as a new result, but actually it's the same pattern. So you see these red ones, it's actually a copy of the same pattern. The researchers present it as a different measurement, but actually it was duplicated. And here this blue one also, is just the same image duplicated. And so this is an example on images, but also on raw data, there are examples. So there is one international study done in several countries, and each country, gets also some funding for that, and they need to achieve a certain number of responses. And there is an example of a country that didn't achieve enough responses to meet this lower threshold, and they collected maybe half of the responses, and what they did is the answers they got in this survey, they just copied them to increase the size of the data set. But then with statistical techniques, it was detected that, this kind of manipulations are easy to detect with statistical software, but also now the technology is improving, and with artificial intelligence, it will be more easy to fabricate data. So we also have to improve our vigilance so that we are always looking for the possibility that there is something wrong with the data, and we need to be extra careful. Here I'm linking a resource, a guide for reproducible research. So from the website The Turing Way, and some guidelines on how to make data, code, and the results reproducible. Okay, now let's talk. So as I'm now coming to so we talked about the trust in science. We talked about how much it's important to enable to be able to reproduce data, but now how to do that? We need to share data. But before we talk about how to share data, let's just first think about what we mean with the word data. We have different sources of data. We have observational data that is captured, data in real time. For example, it can be based on, if we talk about some engineering, maybe based on some sensor data, or in social science, it could be on survey data. So depending on the research field, different sources, but what is in common, that is data based on some observation. Then we have experimental data, which is captured from lab equipment. And it is usually, this kind of data is usually reproducible, but it can be expensive. Examples of experimental data, gene sequences, chromatograms, but also in other fields, we can find examples of experimental data. Then we have data. So these two first types, observational experiment, it's something that we as scientists we collect ourselves in our studies. But there are also cases that we do collect data in a different way. For example, simulation data, data that is generated from test models. So that's also data. For example, climate models, economic models. Then there are examples of secondary data from derived or compiled data that has been transformed from pre-existing data points. Also, this data is reproducible, but again, this is very expensive. And then we have reference or canonical data. So these conglomerations or collections of data sets. And here are some examples from gene sequences, data banks, chemical structures, spatial data portals, and so on. So depending on the research field. So just to have an overview, what are the different sources of research data. And then another thing, so one concept that I will be using and I want to introduce is metadata. Metadata is data about data, that it describes the content of data, their quality, format, source, location, access conditions. So it's like a label that you put on data so that we know what it contains, because if there is no label, you don't know, if it's garbage. So at the beginning, I had that visualization of garbage in, garbage out. So to be able to trust something, of course, it's very important that we have all this contextual information. So metadata is at the heart of data sharing. So just sharing data doesn't have any value if this data doesn't have metadata that's telling us what is the content of the data. And metadata is part of the wider documentation of a study. Metadata is more structured. Documentation is also then non-structured data that we can attach to a study as additional information, but metadata is something that it's structured, organized according to a certain scheme. in a way that it can be machine readable, and the purpose of it is to make somebody who is looking for data to be able to find that data. Yeah, and the documentation is actually a very long process from always as humans. We were trying to document our processes, what we are doing, and this is very important in science. It's not so to make good science, we shouldn't just doing it. We should be also documenting everything that we do, because that's important. And we never know in future. Sometimes we think that an information is not relevant for others, that it's relevant just for us, but you never know what will be the uses of your data in the future. So it's important to be able to document as much as possible and include this in data sharing. Now when we talk about science communication in different phases of the research data life cycle, so when I'm talking about research data sharing, I do it through this research data life cycle. And today I will be talking about the importance of science communication in different phases. The research data life cycle starts with the search for data reuse. So in this phase, so if we are talking about us as researchers, we are at this point we are not producing anything yet. We are just searching for other studies. But what's important here, to be able to find good studies, is important that these researchers that publish them also used rich metadata, so that they used keywords. So they explained the content in an abstract. So when we search data with some search tools, we are able to find data for a certain topic. Because so this is why it's important that when we publish something that we use the appropriate keywords, but also other information. So in which country did the research happen, in what time period, because maybe somebody is interested in a certain geographic location, certain time period. So it's important that whatever we publish has all this contextual information. And then we go to the phase of planning, data management planning. So this is some document that we prepare for ourselves and for other scientists. So it's something that we publish in advance. It's becoming a requirement by several funders, but from the communication standpoint, it's something that we actually write for ourselves, but it's also a good practice to publish a data management plan, because it can be also a useful resource for other scientists, but also maybe for other stakeholders, as I mentioned. Also, the general public might be interested in our studies, and maybe so it's important that this data management, that this data management plans is something that it's shared. So this is also a part of communicating what we are doing. But maybe not as from the view of the general public, maybe not so important as the other ones I will be describing later. One thing that can be also a part of data management planning is also pre-registration. This is a practice that can really is important for improving this reproducibility of studies, and in some research fields, it's already it's becoming a very popular practice, and in future it might become even more in other fields. Okay, but let's now talk about the second phase, which is the data collection. And here the communication can be very important, because especially in social sciences, the data collection involves engaging with the public, with people, inviting them to participate in interviews and surveys. So there is already a long tradition of this involvement, but the science can be also involved on a higher level, and something that can be applied also to other fields to help data collection in many scientific fields. And there are these crowdsourcing approaches where scientists are trying to engage people in helping them gather info, collect data. So animal observations, I don't know, air quality models. So there are a lot of these kind of examples where people ask the public to help with data collection in many fields. And we have citizen science approaches. What is the difference between crowdsourcing and citizen science? So crowdsourcing is just asking people, please help me collect this data, and that's the end of communication. Citizen science is something more. So citizen science involves members of the public to participate in scientific research beyond just helping to collect data. It has also an education value and contributes to increasing public understanding of the scientific process, because the collection of data it also involves maybe learning something. So people, by participating in citizen science project, they also learn about science and they better understand. So this is a very important approach with which we can improve the trust in science. And it's also something very much related to data. So this is citizen science projects are an example of how the participating science, the participating public can learn about the what is behind, just the results of scientific research. They can experience, what is behind, how data is collected, and so on. So this is an important approach that's when we talk about opening up science. In social science research, there is actually also a long tradition, even before citizen science became important as it is nowadays. When I talk about citizen science to some social science researchers, they often, it's mentioned that action research is something that is very much related to that. So what is action research? Action research is participatory research that aims to solve problems while simultaneously also generating knowledge. It's a methodology that is used in it's very popular in educational research. And this is also one way how the public can be involved in scientific data collection and discovery. As I mentioned, for citizen science projects, it's important that it goes beyond just data collection, that we try to involve them also in other phases of the scientific process. For example, also in the data analysis. And in citizen science projects, now it's very popular also. I noticed that some projects are organizing these co-creation workshops, which are sessions where participants work together to generate ideas, solve problems, and design solutions. In case of data analysis, this approach can be used to facilitate group discussion how to analyze data. So that participating public can not only help scientists by collecting the data, but especially in social science research, it's very useful maybe to get some feedback and involve people in data analysis because they might be able to help us to understand the findings of data collection. Of course, this is not something that can be applied to any scientific field, but when it's possible, this is something that can be beneficial to improve science communication. And now we come to the topic of science communication and data sharing. So at the end, even if we didn't involve anyone else till now, It's important that we communicate our finding when our data is collected, and we want when the study is concluded and we want to share it. There is this process of data retention where we decide which data to keep and which not. In some cases, it's not, if there is a lot of data, there is an issue of also having enough space to share it, because it can be a very big data set. So sometimes a decision needs to be made how much to retain and not. And based on the criteria of what should be reused. So ideally, it should be as much as possible because it's difficult to predict future uses. But in some cases, of course, there needs to be, because of the resources, because it's also expensive to store data. Maybe a decision needs to be made what can be shared and what not. But if the data is not like really huge and it's not expensive to share it, of course, we try to share as much as possible. Then the other consideration we need to do is regarding also some legal issues, because maybe some data we cannot share because of certain legal and other requirements, for example, personal data protection laws. So, of course, in social science, if we have some personal data, this is something that cannot be shared, but the data set needs to be anonymized. We lose some information, but this is also important that we meet the legal requirements also, because probably people, if they would wouldn't share certain information if that information would be then shared in a way that they could be recognized. So it's important to respect not only from the legal, but also from the ethical perspective. And then when we decide which data to retain, we publish it, and then another process is the promotion. So we publish data, and then we want to promote it. But for our data to reach the audience so that others can reuse it, it's very important to have rich metadata. So in my previous slides, I was mentioning what metadata is. So from some context when the study was conducted, to the geographical location, to keywords, so that potential users can find our data. The funders are now requiring the data to be in line with the FAIR principles. Today, I will not talk about in detail about what this is, but I'm just sharing a link to this article that is describing them. But if I have to explain them in a very concise and short way, I would just say that the FAIR guiding principles. So it's about the findability of the data. So people are able to find our data based on keywords. Accessibility, there is this known protocol of how to access this data. Interoperability, so that we use standards that make our data interoperable with other similar data. And the R is not reusability or replicability, but it's reusability, so that the data, the metadata is rich enough for others to be able to reuse it. Where to share data? So this is also a topic usually I present various options much in more detail. Here I will just provide a link to this registry of research data repositories that includes different types of repositories. Probably at least our university also has its own repository, and I imagine also several other universities have their repositories, but also beyond institutional repositories, there are other possibilities that are maybe specific for certain research domains. Okay, and now we have another slide, a question. So I'm assuming that you're all researchers and that you are publishing your research. And here I'm interested in, do you publish your research data and where you publish? I apologize for a typo. I had some problems with Slido because of two different PowerPoint versions. So I had to create this slide again really fast in the morning. And I see that I made two typos. But as you understand, so this option is other, and the last one is no research data published. So now, as before, you can respond by joining slido.com and typing this code. And so in contrast to the previous two questions, which are open-ended word clouds, we have a research question that has a limited selection of responses that you can select. So now you will be fast at responding, and I'm interested to see how many of you share data and where you share it. And I'm interested to see what is the percentage of people who haven't published any research data. And those who have published, I'm interested to see where they publish it. Do they publish it in repositories such as Zenodo or the institutional repositories that I mentioned? Or maybe also these repositories can include some domain-specific repositories, or they publish your data as supplementary material in research articles and scientific journals. I noticed that some researchers also use platforms such as Academia and ResearchGate for publishing data. Of course, it's very popular also to use GitHub for research data sharing. Before I show the results, just a comment that, of course, it's very good to use these developers platforms such as GitHub, but at the end, the GitHub is intended for, as a working environment for when the research analysis is happening. But then at the end, at some point, this data should be also published in a repository. So because GitHub is not a repository, so it's and it's actually very easy. There is a connection between GitHub and Zenodo. So we just few clicks for the data that you have on GitHub, you can save it also in a trusted repository such as Zenodo. And then, another option, which is very popular, is sharing data in cloud services from Google Drive to OneDrive, which is something I wouldn't recommend, not because of data protection, but because, this link is not something that on the long term, this is not in line with the practices of FAIR, because of course, if people don't have so only people who have the link can access this data. And this link is not permanent. And so just sharing data in a cloud service is not good enough. So of course, a repository is always a better choice. And then also websites of people projects in the past. So when I started as a researcher, that was more than 15 years ago, in our department, we had a website where we stored all our projects. And at the time, I was thinking that's going to be forever there, but that website doesn't exist anymore. So all the data I stored there is lost. And this might happen also to the website where you're storing your data now. So this is something I don't recommend for scientific data sharing. Among these options, I think only the first two are acceptable. And the first one to be, so not any repository, institutional Zenodo, or any other trusted repository is like the best, but in some cases also supplementing material is okay. Even if in these cases I would recommend a repository, but all the others I mentioned, I don't recommend them. Okay, let's now look at the result. Okay, interesting. So we see that this supplementary material for research articles in scientific journals is the most popular one. And the second most popular option is that data, so 37%, they have no research data published. Yeah, now I realized I made a mistake that I didn't allow maybe more, the option to select more options, because somebody might be sharing data in different ways. So I didn't enable that option, but maybe when I repeat this question in future, I might allow it. Okay, the third most popular one is these collaboration platforms. Then we have only 21% stored in repositories. But I'm happy to see that these cloud services are not so popular, and the websites also not. Okay, thank you very much for your responses. If you haven't responded, you can still do so at Slido. Now let's, another picture from this Data website. I really like this these visualizations they create. So here we have two people saying how life was so much easier back in the day when you just created a table without thinking too much about it. Now people are coming and they talk about this governance, cleaning, protection of data, integration, analytics, and all the things. How nice it was in the past when we just focused on our publishing research findings and we didn't have to deal with data sharing and all this administration related to it. But was it really better? I think it was not so, as I mentioned on the previous slide. I have this experience of sharing, collecting some data as a researcher, and because it was not stored properly, I don't have access to that data anymore. And after that happened to me, I'm much more aware of the importance of following good data management and sharing practices. So this is something that I'm trying to follow because I'm aware that, this data that I might need again someday, because like the primary user of our data that we are sharing is usually ourselves, our future self. So whenever we are dealing with this data management planning, data sharing, we always have to think that this is something we are doing for ourselves so that we are better organized, because you never know when you might need to use your data again for another project. Okay, we have now almost 1 hour. I prepared, so we will have now a short break, but before we take this break, this will be an active break, so you can also use it to for other things, but I would, because this is a workshop and I want to be interactive, so I will give you a task to do in this time. So in the beginning of the presentation, we were talking about trust in science, and I showed the result from one study about trust in science. It was this Eurobarometer study. And here I'm introducing another study, more recent one. So at the beginning of this year, Nature Human Behavior published an article titled Trust in Scientists and Their Role in Society Across 68 Countries, based on a survey they conducted between November 2020 and August 2023 within their project. And they come to some very interesting findings. Especially, I would like to focus on figure 1 in their study. So I'm aware that you don't have my slides and that you cannot click the links. So I will put these links into the chat after finish speaking. So you will get this link in Slack. And so I want you to compare the figure 1 in this article to the data about the study I already presented today on slide 10. I will include the link to that study, and specifically, so this figure. So I will provide the link in this study from 2021. And then I want you, so you are coming from different T4U countries, and there is 8 countries for which data is available for both studies. That's Slovenia, Spain, Bulgaria, Portugal, France, Germany, Italy, or Poland. Unfortunately, this first study doesn't have Estonia and Lithuania. So if you're coming from some other countries or countries that are outside from T4EU, feel free to select any of these 8 countries, but preferably, of course, select the country you're coming from, or if your country is not on the list of these 8 countries, select any other country. So after you select which country you want to focus on, look at both these figures and articles and try to respond to this question. So the first question is, what do the 2 studies reveal about trust in science in this country? Are the results consistent between the 2 studies? If not, what might be the reasons for the inconsistencies? And then, in your opinion, which study presents its results more effectively? Which results do you find more trustworthy and why? So let me now share the links in chat. And I suggest we take like maybe, let's say 15 minutes so that you have enough time to prepare. Sorry, find chat. Okay. So this is the article in Nature. I don't know if you see. So the article, specifically this figure 1, I will add also the link to this figure. So this is the 2025 study, and you look at the data for the country that you're coming from, or the country that you want to focus on, and then the second study I will provide this report. So I'm entering into chat. So this is the Eurobarometer study that I presented at the beginning. And inside this study, you will see a report. And if you download the report, you actually have it in different languages, in 3 languages. You also have it in German and in French. I worked in the English version, so there is a PDF that you can download. And on this website, there are also other information about this study. And for this study, I will type, so it's the, so this is the, we'll type it to check. This is the question in this study. And maybe I will try to put the image. So now it's 10 and 10. And I suggest that, so you take the time. So I said 15 minutes. So that will be at 25. So 10:25, we continue. And in this time, try to respond to these 3 questions. So just in case, I will also copy the 3 questions to chat. And then I will be asking 1 volunteer for each country to report something. So for each country, I will ask someone if they want to report. Yeah, so these are the questions. And I will just. Another thing I will try to post in chat. Okay. So this is the image that yeah. Okay. So I think you have what you need. And this is the first time that I'm doing this exercise. I hope that this 15 minutes is enough and you were able to understand what the task is. So also, if you didn't respond to all the questions, I hope that you were able to respond maybe at least to a few of them. And I would now need a volunteer. So can somebody raise their hand and volunteer? Maybe, okay, yeah, I see a hand. So it's Alexandra Tsvetkova. So Alexandra, please, which country did you select?
I'm coming from Bulgaria, so
Bulgaria.
I researched about it.
Okay, what did you find out?
So comparing the two studies, Bulgaria somehow ranks below the average of the European Union. In the first nature study, Bulgaria weighted mean score for trust in scientists. The score was 3.45 on a 5-point scale, which is 1 is very low trust, 5 indicates very high trust. And this score places Bulgaria slightly below the global average. And then the second Eurobarometer study puts 50% of Bulgarians expressed trust in scientists, which is below the European Union average of 66%. And this indicates that Bulgaria has one of the lower levels of trust amongst EU members. Comparing both studies suggest a moderate level of trust. And this means that there is work to be done.
Did you find that the results between the two studies are consistent? What you found in one study is consistent with what you found in the other one?
I would say this depends on the goal of this comparison. I mean, if you look from a perspective of EU specific policy development, for example, the Eurobarometer study is more aligned with institutional needs. But then the nature human behavior study is more effective in terms of the broader reach and the scalable methodology. So it's dependent of how it looks. And also we have to have in mind that they have been done in different periods of time.
Of course, yeah.
Also,
the question asked was
the main
very
question asked was very tricky, I would say, for in one of the studies, because when you ask a question that has a negative tendency in it, you receive different responses.
Yeah, that's true. Yeah, it's cognitively can be difficult to respond to this kind of negative question. And of course, yeah, the nature human behavior study, it has a list of different indicators to measure it. So from, I know that 15 minutes is short, but in this time, from what you were able to read about these two studies, in your opinion, which study presents the results more effectively? What is your impression?
I think this should be the nature human behavior study. I find it a bit more effective.
And more trustworthy.
Yeah.
Okay, why is it so? What are the reasons?
Because of its methodology, from what I was able to see, and also a bit a broader reach, I think it presents.
Okay, thank you. Do you feel that this 15 minutes was enough, or would you appreciate more time for reviewing the two studies?
Of course, more time is needed. This is just like a quick look.
Okay, yeah, like the first impression. But I think it reflects well how, the general public that might be looking at our studies, how much time they are able to invest. So from this, I hope that 15 was like good enough to have an impression. Maybe just one comment I wanted to make before, but I didn't. I wanted to say that here there are like no wrong or correct answers. So regarding this trustworthiness, so I'm interested to hear how you perceive it and what do you think. So how would you compare the two studies? So based on your impressions. Do we have another volunteer maybe for another country? Can somebody raise the hand? So is there someone who did it? Okay, yeah. Okay, we have Patricia Carvalho. Patricia, could you
Yeah.
present?
Hello, I'm from Portugal. So answering the three questions, can you hear me well?
Yeah, I hear you. I hear
Okay,
you well.
good. So answering to the first question, I think that in the nature study, we can see that Portugal is in the middle, which means that he's a weighted mean for trusting scientists is 3 point, give me a minute, sorry.
57.
Yeah, exactly. So being 1 very low and 5 very high, I think this is a relatively high mean interest in scientists. Otherwise, in the Eurobarometer, we see a different result, but I think that it's hard to do this comparison because in the Eurobarometer, we are exploring the trust in scientists in a specific theme, which means the truth about controversial scientific and technological issues and related to money. So I think it's very hard to do this comparison, but I don't think it's a bad result. In the second question, so I think I already kind of gave the answer to it. It's different survey methodology, so it's kind of hard to do this comparison. And in my opinion, responding to the last question, the Eurobarometer is more effective and probably I would say more trustworthy because it's conducted by the European Commission. So the last thing that I would like to say is that probably, especially for the Nature article, a little bit more of time would be better to analyze it better too. Thank you so much.
Thank you very much, Patricia. Do we have a volunteer for another country? Do we have someone from Spain maybe? France, Germany, Italy, Slovenia? We have Poland maybe. Anyone from Poland? So far we had Bulgaria and Portugal. Now I'm looking for someone from maybe, okay, we have maybe someone from Spain, Germany, France. Anyone? Slovenia maybe? Okay, I see no raised hands, but no problem. I think already the 2 volunteers we had, I thank you very much. We got some insight into what are the different things we look for when we are evaluating how much we trust. So on one hand, we have this human nature behavior study, which is, peer reviewed. So it's published in a scientific journal, it's peer reviewed. And what is also trustworthy is that all the data is shared, the methodology is shared and explained. So if we would have maybe more time to look into the details, you would see that, these 68 countries, like the methodology maybe between the countries was not like really consistent. But we know what we know is that the article was peer reviewed, was published in a scientific journal. On the other hand, we have the study, a professionally done study that is accessible through the European Commission website, through Eurostat. Eurobarometer has a long tradition. They have very rigorous methodology. I know these things as a scientist. I don't know if the general public is aware of that. So it's data that we really trust. on the other hand, how data is, so we have this documentation, but we don't have like all the background data to the same level that we have in the nature human behavior study. And also, as it was pointed out, maybe the question, the way in which the question was asked, this negative way, might impact the results, and maybe there is some error and bias regarding that, how people understood that question. So this might be also then an issue. So as I said here, there are no correct or wrong answers. So what I was interested in is to hear your perception. So when you are comparing two studies, what are the things you notice about the communication? We could be also looking at the graphics. I think how it is presented. This Eurobarometer study, it's really nice that they have these flags, and it's really, you can find the question quickly. That figure in nature human behavior, maybe it's not so much readable because the flags are smaller, and also the list of countries is very long. And also it was a bit confusing to know exactly how this trust was measured. For example, in this Eurobarometer study, we have above the data, we have the exact question, how it was asked. While for the nature human behavior study, I had to find all we just know that it's trust in science, and that 1 means like the lowest point and 5 means the highest point. But we don't know what exactly was the question, but this information is provided in the supplementary materials. You can go there and you can find the exact questions, and you see that it's in an indicator based on several questions. So we can access this information. So yeah, the two studies are very different. So I wouldn't select one and say this, I like this one better than the other. They're very different. They both have positive aspects and things that could be improved. And I hope this, example of comparing them and looking for details behind the methodology is something that you find useful, because this is a process. So as researchers, when we publish something, we need to be aware of our users. So in this exercise, when we were trying to go into the role of somebody who is looking at our data, so, to go to be in that situation and think, what is the information that is important for people who are looking at my data. So when we publish our data ourselves, what we can do to improve the usability of our data, to improve the trust of the users of our data and our data. So I hope that I inspired you to think about these questions. Now, before I continue, I would ask you if at this point you have maybe any questions for me. Or should I continue? Just a moment, let me find the chat. Okay, so I don't see any hands raised. So I will just continue with the presentation. Yeah. Okay, yes, so sorry. Yeah, I thought I would show you before. So this is in this nature human behavior study. So the arrows are showing which are the T4EU countries. Actually, here we have 9 of them because we also have Ukraine, but we don't have Lithuania and Latvia. Latvia, yeah, and we have this weighted means. And we see, so this line is the median, and we see that Slovenia and Spain are above the median while others are below. And, for me, I looked especially in Slovenia. It was surprising because in this study, we see Slovenia and Spain above the median, above the average in the trust, while in the Eurobarometer study, they were the countries that were among the worst. So this was then surprising, and this inspired me to prepare this exercise to have a look at that. But of course, as you notice, the question how it was asked about trust, it's a very different way. So it's a different concept. So this trust index is multidimensional, and that one in the Eurobarometer study is based on a specific just one question, which is very specific. Okay. Okay, I have a question. So if I have any examples of case studies of co-creation being used with the audience for data analysis, it is something that I'm planning to do in one of our projects that the Research Institute were working. But I know about the citizen science project in Slovenia that did that. And what they did was they did an evaluation. They were interested in, they were like architects or urban planners. And they were interested in evaluating how people perceive entrances to health centers in Ljubljana. So they did a study. They were collecting data. They had interviewers with a survey that were collecting data in front of health centers, different health centers in Ljubljana. And they collected this data using this paper questionnaire, or it was online, I'm not sure. But what they did, they also collected the contact information of the participants. And when they finished with data collection, they invited participants to this co-creation workshop. And some participants joined, and they showed them the results, and they were together interpreting the results. And this way, because, you know, in a survey, you have, you know, a structured response. Of course, you can offer some maybe open questions, but this enabled them to then get the feedback from participants, and these participants help them analyze the study. And this is a very good example because, you know, in citizen science, sometimes you just use people that help you collect data. I don't know, you're asking them for observations of birds or things like that. Or in a classic social science survey, you judge people for a response and that's it. But at the end of the process, here people were involved in how science or how analysis of research data was done. So people were involved in that, and they had the opportunity to see how this knowledge, how the analysis is happening, what are the things that researchers do. And this, of course, is something that is a good example of engaging the public in the scientific process, and with that also increasing trust in science. So this is an example of a study I know. I don't know if they published anything in English. So what I know from the study is from a conference presentation they had, but there are of course many more. There are also other examples of this kind of approach in other projects, but maybe I don't know so much more details about regarding that. Okay, let's continue with the presentation. There will be some chances for some more questions at the end. Actually, I don't have many more slides. What I have is some additional resources. So I could have listed a lot. I have many more, but then I decided not to make too many. So I selected just a few that I really like. They're not super new, as you see. So there is this United Nations Economic Commission for Europe guidelines on making data meaningful. And they have this guide so the first one is a guide to writing stories about numbers. The second one is a guide to presenting statistics, a guide to communicating with media, and a guide to improve statistical literacy, because that's also very important when we work with data. And these are topics I didn't cover in this presentation, but I think, so what I focused today was, you know, how we share data. We need to have rich metadata. We need to share as much methodology as possible. But when we when we write a paper, when we write a report and want to communicate things, you know, this storytelling is very important, you know, how we present data in our article, because that's the first thing people will be reading. And these guides provide some very good information. And I think I didn't cover these topics in my presentation. I was considering to, but then decided to go another way. So I'm providing these resources here for you. You will receive the slides and you can then read these reports. They're very short, but they have very good advice. The second two resources, so when we are doing some graphics, so, some charts for our research paper, for our presentation or representing data, I believe that, you know, a good visualization in some cases can be done also in Excel. So you don't need the knowledge of programming. So even in Excel or in SPSS, you can do a good chart. But in some cases, if you want to do something more, if you want to do an interactive chart, I think it's useful to learn some more advanced tools. So I'm providing here a link about data visualization with R, and then the interactive visualizations with Shiny. So I'm using R for a lot of times. I'm just using Excel for data visualizations, but in some cases, when Excel is not enough, I'm using R. And Shiny is something that I'm aware of as a user. So I'm using the visualizations people prepare with Shiny, and it's something also on my to-do list to do that. So I'm including this link as a resource for you if you want to learn more. Yeah, so this is the selection I made as for additional resources for additional reading. I want, before I give you the opportunity to ask more questions, I want to end with a quote that I think is also in the context of the this workshop I had today. And it's, you know, somehow connects this data, so data analysis, statistics, and citizenship, you know, involving the public. These skills of statistical literacy is not a skill that only we as researchers should have, and not even every researcher has this skill, but I think they're very important to have, because almost in every scientific field we work with some data, so it's important to have this statistical literacy and knowledge. But also as a citizen, as a good citizens, it's important to have, because we are in a society that we live in societies that based on a lot of decisions on data, and it's important to be able to understand how data is made, how data is used, how data is interpreted. And this is a quote from the previous century, from 2000, from 1903, from the book of H.G. Wells, Mankind in the Making. And I think, you know, this quote was made before even we had computers and all these opportunities to analyze data. But already at the time, there was this awareness that these skills, the training in mathematical analysis, it's very important for being a good, an efficient citizen, to understanding all the complexities of data of the world. So these skills should be as important as it is important the ability to read and write. This skill of having the required skills to be able to understand the context of data, how to use it, how to analyze it, how to interpret it. It's is a skill that's very important. So this is, I wanted to end the presentation with this quote, because I think even if it's more than 100 years old, it's still very much relevant today. So it was a good prediction of how essential this skill is nowadays. Okay, and now we have 5 more minutes for your questions. I see there is already one question. Okay, this was a thank you for the example. And now, are there any more questions from the audience regarding anything that I presented today? So you can raise your hand or you can ask it in chat as you prefer. I don't see any hands. So if you're not asking, then I will ask. So I will ask again. So I will again ask you to fill out this evaluation form. Okay, I see another comment. Another question. So I mentioned the data management plan. Should this be released, promoted prior to any publications or data collection? Okay, so yeah, so the data management plan. So in my case, so I published. So when I prepared it, it was instantly published. So maybe in some cases, researchers somebody might perceive, this is like something that you don't want to share with others because others might copy. But in my perspective, from looking at the trust in science, I think it's a good thing that several scientists do the same thing, because this is what this reproducibility, replicability is about. So I would advise of sharing the data management plan as possible and not hiding it, because you can also get feedback from other scientists regarding your data management. And it's also an example because maybe other researchers, they need to prepare a data management for their research, and they might find inspiration in your. Okay, so I realized that it was a direct message to me, so you didn't see the question, so I will read it. The question was that I mentioned the data management plan. Should this be released, promoted prior to any publications or data collection? So my answer here is yes. And maybe a point I wanted to make earlier, but I didn't make. So whenever you are publishing data in a repository or in a publication, I think it's always a good idea to increase like the reuse of data, to share this data also on social media. So I don't know which social media you use. The next workshop in this series will be about social media use. So you will learn more about that topic there. But me personally, in the past, I used Twitter a lot, now not anymore, because Twitter, as it was, it doesn't exist anymore. So now I'm relying mostly on LinkedIn. So if I publish a data set, I will also promote it on my LinkedIn. One good thing to promote it is usually when I publish a data set, I write a popular science article about it, where I present what the article is about. So because, I have the scientific article that presents the research and cites the data, but I think that it will reach more users maybe if I also write a popular science article that's presenting the data. And of course, there is also one option also to write data papers. I'm actually now a co-author of an upcoming data paper that will be published soon. And I think that's also an example of a good practice. Any more questions at this point? Okay. Yeah, I'm happy that you find it useful. And useful, as I said, I will share the slides. And don't forget, if you want a certificate of attendance, please contact my colleague, Sanya, on the email she provided in the chat, and she will send you the certificate of attendance in case you need it. And yeah, of course, don't forget about the form. Yeah, we have 2 more minutes.
Good morning.
For any final feedback. If not, I will wait 2 more minutes if there are any other questions. If not, I thank you all for your attention, for all the questions and participation. I hope it was useful for you. Yeah, thank you for listening, and I'm really interested in the feedback because it was the first time I presented this topic in this way. I used some content from other presentations, but there was also a lot of content that I presented for the first time. So it would be really useful to get. I'm happy that it was useful.